Hey guys, welcome back to my channel. Today we are solving Leetcode problem number 19, that is remove nth node from end of the list, right? So basically what is given in this question is we have a singly linked list, right? And we have n, okay, n equals to 2. So what we have to do, we have to we have to remove the nth node from the last of this singly linked list. For example, in this case, this node is going to be my first last, this is going to be my second last, right? So we have to remove this node, right? Because this is the nth node, right? So we have to remove the nth node from our singly linked list, right? So without wasting time, let's see the bruteful solution. So the bruteful solution is, what we're gonna do, we're gonna iterate this singly linked list first of all and count the number of nodes present in this singly linked list. So right now, if I'm gonna iterate this singly linked list, so I get something 5, right? Because in this singly linked list 5 nodes are present, right? And then what we're gonna do, we're gonna subtract 2 from it, which is going to be my n. We're gonna subtract n from it, okay, which is right now in this case is 2, right? So we're gonna get something, right, 3, right? So we're going to iterate it again by 3 times, right? And if I'm gonna do, so we're gonna get this node, right, which is going to be 1, then 2, and then 3, right? And then basically what we're gonna do, we're gonna link these two nodes together, right? That is going to be, we're going to change the next of this node, which is going to be next dot next, right? Which is going to be this node, the last node. And this is how we're going to skip this node, right? So this is how the bruteful solution look like, right? But the time complexity of this solution is going to be big O of n square. Why? We're going to iterate it first, and then we're going to find the number of nodes, and then we're going to iterate it again by this time, right? So we're going to get something, in worst case we're going to get n square, right? Big O of n square. The time complexity will be big O of n square. So now let's see the optimal solution, how we're going to solve this problem optimally, right? So to solve it optimally, we're going to take 2 pointer, which is going to be our front and back. I'm going to take 2 pointer, which is going to be front and back. Initially these two pointers are going to be point, I'm going to take it, these 2 pointers are going to be point to head, right? Initially both are going to point head. Now what I'm going to do in this question is, I'm going to move this front pointer ahead by n, right? I'm going to accelerate it. First of all, I'm going to accelerate it, this front pointer, by n, right? Which is going to be 2 in this question. So I'm going to move it ahead by 2, right? This is going to be my first. This is going to be my second node, right? So I have to accelerate it, right, by 2. Okay, and my this back node is going to be point this front node only. Now, in this case, if my front is already been accelerated, right, and pointing some node, and also we have a back pointer, right? Now, in this case, what we have to do, we have to move these 2 pointers, right? We're going to move these 2 pointers ahead, right, by 1 step again and again. We're going to move these 2 pointers simultaneously ahead by 1 step again and again. How we're going to do this, and how much we have to do is, right? So until my front dot next is not equals to none, I'm going to mention this point, right? Until my front dot next is not equals to none, right, is not equals to none, I'm going to iterate this. I'm going to move these 2 pointers ahead by 1 step again and again. So let's do this. I'm going to move this front pointer ahead by 1. I'm going to move this back pointer ahead by 1. And then I'm going to do again this front pointer. I'm going to check this. Front dot next is equals to none. No. Let's move it ahead. Now let's move this pointer also by 1. I'm going to check it again. Like my front dot next is equals to none. Yes, in this case, my front dot next is equals to none. Means this is the time this is the time that we have to stop, right? At this moment we have to stop. Why? Because my front dot next is equals to none, right? Now, so do you see we get those nodes, right? We get those nodes that we have to link these two nodes, right? We get those nodes that we have to link together, right? What we have to do, what we're gonna do, we're gonna link these two nodes. What I'm gonna do, I'm gonna link these two nodes together, and this is how we're gonna skip this node, right? So what actually we have to do, we're gonna do back dot next equals to back dot next, which is going to be our last node, and this is how we're going to skip or get rid of this node, right? And we want to rid of this node, right? So this is how we have to solve, and this is what the optimal solution looks like. And also we have some edge cases, right? So if n equals to 3, right, if n equals to 3, so in this case what we have to do, we have to delete the third last node, which is going to be, this is going to be my last node, this is going to be my second last node, and this is going to be my third last node. So means we have to delete this first node, right? We have to delete this first node. So how we're gonna do this, and this is how, and this condition is going to be our edge case, right? So let's see why this condition is edge case. So basically, if I'm going to take my front, okay, if I'm going to take a front which is initially going to point head, and also I'm going to take a back pointer, right? Initially both are going to pointing head. So we know that we have to accelerate this front pointer by 3, right? We'll have to move this pointer ahead by 3. Okay, so I'm going to move this 1, then 2, and then 3, right? First we have to accelerate this front node, and then we have to move these 2 pointers 1 steps ahead simultaneously, right? Then we have to do it. First we have to move this front node. So what I did, I'm going to accelerate this front node by 3, right? So what I saw actually in this case is my front, actually if you will see, my front is equals to none, right? In this case my front is equals to, already my front is equals to none, right? So if I'm going to apply this case, isn't it work? Do you think this case is going to be work, right? No, right? So in this case what we have to do, if our front is equals to none, what we have to do, we have to delete this first node, right? If our front is equals to node, if the front pointer is equals to none, we have to delete our first node, right? And also you can check, like if my n is equals to len of this node, right? But we don't know now len of the node, right? We don't know the len of node. That is why I'm doing this. That is why I'm putting this edge case, like if my front is equals to none, we're gonna remove this first node. So how we're gonna remove this first node? We know this first node is actually our head, right? Actually our head. So this second node is going to be our head dot next, right? Head dot next. So what we're gonna do, we're gonna return head dot next. We're gonna skip this first node, right? If we're gonna return head dot next, so our singly linked list start from second node, right? It will be going like this, 2 and 3. We're gonna skip this front node if our first point, if our front pointer is equals to none, right? So this is how our edge case look like. Now let's see one more example. If we have only one node, right, and n is also equals to 1, so in this case, if I'm going to do my front and also I'm going to point my back, both are pointing to this, right? And what we have to do, we have to move our front pointer by n, which is actually going to be none, right? So nothing we have to do, we're going to return something empty, right? If I'm going to accelerate my front pointer, let's say if I'm going to accelerate my front pointer, so it will be equals to none, right? And back is pointing to this, right? So in this case we have to return what we have to return. In this case or this case, both are same. So what we have to return, if my front is equals to none, so what we have to return, head dot next. So in this case, what is this? This is my head, right? Or head dot next is actually none, right? We don't have second node, so in this case we have to return something like this. For head dot next we have to return, right? So these two cases, this case or this case, both are same, right? Both are same. And this is how we have to do, right? So let's see the coding part. Okay, so what I'm going to do, I'm going to take 2 pointers, right? Front pointer or back pointer. Initially both are going to point head, right? Head of my singly linked list. And then I'm going to accelerate my front node by n times. Okay, so let's do this. Front, okay, for this in range n, right? What we have to do, we have to move our front pointer. Front equals to front dot next, right? And also we're going to manage here our edge case, like if my front equals to none, right? And if in case my front is equals to none, what we have to do, we have to remove the first node, right? So we have to start returning our singly linked list from second node. So for that we have to return head dot next, right? And now let's do this. While, until and unless my front dot next is not equals to none, front dot next not equals to none, what we're gonna do, we're gonna move our front pointer or back pointer simultaneously one steps ahead again and again, right? So what we're gonna do, front equals to front dot next, and also I'm gonna do back equals to back dot next, right? And at the end we're gonna do back dot next equals to back dot next, right? We're gonna link back dot next, right? We're gonna link those nodes, right? So that we're gonna skip the nth node, right? And we have to at the end return head, right? So this is how our code looks like. So let's run this code. Yes, it is accepted. And also submit this code. So it has been submitted also.